Here we have 3 x's. They are equal to 6. If the way is to put this one down, in order to get 1x, but then how do we get x right here down? There's no x. Besides, structurally, if we do 3x minus equals 6, so this 3x minus 2x, which is certainly equals to 1x, if we do 6 minus 2x, then we'll get x equals to 6 minus 2 what? We'll still not get anything. If it is still in x form, then this is still x and this is still x. And if we move it here, then it becomes x plus 2x equals 6 and back again to 3x equals 6. Since this is negative, when we move it is positive. So another way is, since these 3 things have the same value, each of these x has the same value, we may be thinking that let's divide this into 3 equal parts. Yes, so we get this 2, and this 2. So the right thing would be 3x equals 6. And this 2 is the value of this 1x right here. So now it's 1x equals 6 divided by 3. And thus we get x equals to 2. That's why sometimes some people say, if it's multiplication right here, when it's on top like this, when we move it to the right side or to the other side of the equal symbol, the top, which is what's supposed to be here, would go down to become a denominator. From numerator to be a denominator. Let's see the next question. So here there are 2 x's. There's 1, 2, and they are equal to 6. To do this one, we want to get the value of this 1x. So structurally, it's 2x plus 2 equals 6. Let us bring down this 2 first. So now we've got things that are in x only, which means right here 2x equals to 6. If we bring down 2 right here, we must also cut 2 to bring down right here, so it becomes 4, right? So 6 minus 2 directly. That's why some people say if it's positive 2 right here, when we move it to the other side of equal symbol, it'll become negative 2 or minus 2. So now 2x equals to 4. Again, each of these x has the same value. So let's divide this 4 into 2 equal parts. Therefore, x equals to 4. There should be 2 right here, but it's moved down. That is the other term, so we can divide. So x equals to 2. I would usually use the term that if it is at the top, it moves down, then becomes denominator. Sometimes it's easier to be understood by some people. So next, right here. Here we can see that this is 6 equals to x. If I divide this into 3 equal parts, So this become 1/3 x, 1/3 x, and 1/3 x. If I take these two parts away, the scale will not be balanced. It will be heavier on this part on the left side. And in order for this to balance, I need to divide this 6 into 3 parts. Certainly, we know that this is going to be 2, 2, and 2. Then I'll take this away. So in this case, a new case is 1/3 x equals 2. Sorry, in order to make this structure better, I'll follow the order of the writing, which is 2 comes first, then equals 1/3 of x. Or we usually say that 2 equals to x over 3. Now the question is how to find the value of this x back. Since that it was said that this 2 were taken away, we can just say, okay, it's 2 plus 2. But then when we want to add here, then we have to add plus 2 again, and then we'll still remain with x if this is 2 plus 2. So the other way is, since this is 1/3 of x, if we want to get x only, we'll add with another 1/3 of x, add again with 1/3 of x. But then here we must also add with 1/3 of x. We must also add with 1/3 of x. We must add the same thing on the left side with what we add on the right side. Then we'll still get this x. It will be like this: 2 plus 1/3 of x, 1/3 of x equals to 1/3 of x, 1/3 of x, 1/3 of x. Then this will become 3x over 3, right? But then we'll have x again on the left side. So instead, since that 1/3 of x plus 1/3 of x plus 1/3 of x is adding by 1x, 1/3 of x for 3 times, then we may just want to multiply this this x over 3 by 3 times. So if this is multiplied by 3, here on the left side is also multiplied by 3. So now we'll have 6 equals, this 3 divided by 3 is 1, 6 equals to x. Or x equals to 6. We may read this either from the left side to the right side or the right side to the left side. Let's say if there's 2/3 of x equals to 6, and we are asked to find the value of x. So we may do 2/3 divided by 2/3 x, and then 6 divided by 2 over 3. So here we get x equals to 6 times, because 2 over 3 divided by 2 over 3 is 1, and then 1 times x is x itself. So you get x equals to 6 times 3 over 2. When division becomes times, the numerator and the denominator have to be flipped. So x equals to 6. I'm sorry. I'll just directly cancel this. 6 divided by 2 is 3. So 3 times 3 is 9. This is also why sometimes some people say we can do cross product. Let's say it's 2x over 3 equals to 6. We want to find only the value of x. So this 3 may go up here. So it becomes times, but I'll just write down below later. And then this 2 will go down here. So if you write, so it becomes x equals to 6. As said just now, 3 goes up, so it goes up here times 3, and then 2, as it goes down, so it becomes denominator. So that's why sometimes people say we can do cross product. So this 3, which is denominator, now becomes a numerator right here. The 2, which is a numerator, now becomes a denominator. So now x equals, we may just cancel this out. Divided by 2 is 3. Divided by 2 is 1. So we are left with 3 times 3. And that is 9. Again, we may read this from left to right or right to left. Let's say 6 equals to 2x over 3. So 6, this goes up, times 3. This goes down, divided by 2, equals to x. Cancel this. This is 3. So now we have 3 and 3. 3 times 3. And here is 9 equals x. Or x equals 9.